Hi, welcome to ISE503. This chapter or this lecture is on fundamental concepts of database management, part 1, and the lecture slides are from our textbook, which is Principles of Database Management. In this lecture, we will look at the basic concepts of database management, which will involve some basic definitions, some very important concepts, and some applications as well. So I will start with the application. There are so many interesting and useful application of databases. So let's look at some very important ones, some very fundamental one that we come across in day-to-day life. So the first example that we have here is about the storage and retrieval of traditional numerical and alphanumerical data. So this is a simpler version of data compared to the other examples you would see. Now here in the first example, which involves the storage and retrieval of traditional numeric and alphanumeric data, this is for inventory application. Now for inventory application, we can think of different scenarios. Let's think of a very simple scenario of corresponding to a small general store owner. So the general store owner needs to keep track of the different products that the owner has in his store. Okay, and that information will be stored in the inventory application, which will have the number of products, the name of the products, the quantity of the products, and the price of the product. Okay, and this is a simpler database because the data is going to be numeric, like the price is numeric data, the quantity is going to be numeric, and then alphanumeric, where we have the alphabets as well as the number. For that you can think of the product number. Okay, so the product number may have the character as well as numbers. Product name you can think of. You will have the data about supplier as well. So this is a simpler example of the database application. Let's look at slightly interesting one which we use very often in day-to-day life, right? I use YouTube a lot, and I would assume that a lot of you people use YouTube, and some of you might be using Spotify as well. Now the second example that we have is the example of a database where the data that we are storing is multimedia data. It's not like the previous one where the data was slightly simpler, just numeric and alphanumeric data. We have the applications like YouTube and Spotify where the data that we store is multimedia data, like YouTube has videos, Spotify has songs. And yeah, we can use these applications to search for videos on YouTube and songs on Spotify. Let's move on and look at one more class of database or database application, biometric application. Okay, so this we find more often when we are traveling internationally for security systems. And in the security systems, say if you're taking an international flight, then they might take your fingerprints. Okay, and in some cases they might even scan your retina. So here again, the security system that they have, they are also storing some data, but that data is biometric data. So three interesting examples of database applications, the three different kinds of data. So now these wearable devices, if you think of, they are also coming very common. You would find probably every next person having either Fitbit or Apple Watch or similar devices. So these systems are also tracking your data or storing your data. All right, so let's move on and look at a few more examples of databases. Geographical Information System, GIS, and the example of that is Google Map. So if you're traveling as an example and don't know the destination, I mean you've never been to the destination and you want to put that in the map, could be Google Map or any other map system that you use. There also you're interacting with a database, and in that database we have the maps stored. Okay, and this kind of data falls in the category of geographical information systems, or GIS in short. Similarly, you can think of a sensor application. um, it's slightly complex, could be used in places like nuclear reactor. They might be, you can assume that nuclear reactor is not a small thing, a huge system or an enterprise, whatever you want to call it, with so many things at stake, right? So many controls, so many measures they might be doing, like pressure measurement, the temperature measurement, so on and so forth. So for that also there must be some sensors there. The sensors are monitoring those values and storing somewhere in the database. And then we can think of the big data as well, because now, you know, big data has become very common. It's not a new term anymore. So think about the giants like Walmart, right, with so many locations and so many customers visiting them every moment, every minute, every hour, I would say. And these big enterprises like Walmart, they are tracking all the data. They want to know which customer bought what product, in what quantity, in what location. Okay, because that data is of their huge importance. They would do some analytics on the data that is being collected in their point of sale. Okay, so the kind of data that Walmart is storing is huge one. That's the reason it will be called big data. But here again, the data would be stored in some database only, which will involve the application of database technology. And then, well, these things are comparatively new, I would say, like Internet of Things. You can put some devices in your house, and those devices are smart devices. They will probably measure the temperature outside, and on the basis of that, they will adjust the room temperature inside. Okay, so these things are very common these days, like Google Nest and all, if I'm not mistaken. So these devices are also storing data in every second, right? So that data is also something that needs proper management, and these are also some interesting applications of database technology. Okay, so before we get to the details of database management, database systems, and the definitions related, we should go back and look at how the data was stored when we did not have database management systems. So I would assume in the beginning, right, probably say, I'm just guessing, maybe 40 years from now, 40 years back, right, when we did not have, I just came up with this number 40, right? You can replace it with X. What I'm referring to is in history, when the computation just started and when we did not have database systems. So that time a typical application looked like this. Okay, so here, how the data was managed in that kind of scenario, data was managed using files. Okay, so here look at this scenario. There are these applications. For the convenience, I'll use some number. I'm putting number 1, number 2, and number 3. These are 3 different applications. One is invoicing application. The second one is CRM, stands for Customer Relation Management System. And then you can have GIS, you just a Geographical Information System. So these are 3 different applications running. But how are these applications running? They all need data. Okay, but for their data need, just look at this part over here, right? Invoicing would need some data, and that data is coming from the file. All right, so invoicing application has a file from which it is getting the data, and the data has customer number, customer name, and VAT code. Good. And how about the second application? Second application is CRM. CRM is also dependent on data, and CRM has its own file which has customer number, customer name, turnover. And similarly, the third application, GIS, is accessing a file with customer number, customer name, and zip code. Good. So seems okay, right? Not that bad. But let's think about the disadvantages with this kind of scenario. So, I will first of all make sure that whatever I have in the lecture slide is covered, or in this picture is covered. So if you pay attention to these files, file A, I'll call it file B, and file C. In these three files, if you pay attention, then you'll find that the first two fields, which is customer number and customer name, these are duplicate. Okay, which doesn't look good because duplication can create a lot of problems. Later on in the course, we will learn about redundancy. Technically, the duplication is called redundancy in databases. So redundancy can result in a lot of problems like anomalies and all. We'll learn about those things later. But right now you can see the same thing. Okay, and we have the duplicate data, which will first of all result in inefficient storage utilization, and at the same time it can also result in inconsistency, because the customer number or something may be changed in one file. Say there was some issue with the customer name and we want to change that in one file only, whereas the other two files, they will have the previous information. So when we have duplicate information, then there are chances of inconsistency. Okay, so that is one disadvantage. So in the next slide, you will find all these disadvantages listed systematically, itemized. But let's discuss one more disadvantage associated with the file system. Each application like invoicing, CRM, and GIS, there we needed the code for handling the data. Okay, so in other words, you can say that the data definition needs to be handled in each application, which makes it very, very inefficient. Okay, so with this much of high level information, let me take you to the next slide where we'll have these things more systematically discussed. And here we go. The file approach. As we have just seen in this picture, the file approach will have duplicate or the redundant information. It will be stored in different files, and all depends like how many applications do we have. In the previous picture, there were three applications and each application needed one file, so we had three files. Danger of inconsistent data, right? As I pointed out, if the customer name has been changed at one place, okay, because probably the name that was entered initially was incorrect and needs to be fixed, then that fixing might be done only one place in only one file. The other files may be inconsistent. So inconsistency happens when you have made change to one file. I'm saying file here because our context is file, whereas the information in the other file is different, right? Where the data is different in different files. That is data inconsistency. Now, this point I was referring to in the previous picture when I said that the data definition resides in the application. So the same thing can be phrased this way. Here we are saying that we have a strong coupling between the application and the data. What does it mean? That simply means that if you make any change to the data, or the data, the way you have structured your file, the way you have stored your data in your file, then that change would result some change in the implementation of the application as well, because your whole logic behind accessing the data from the file is also written in your application. Okay, so there is a tight coupling between, or a strong coupling you may call, between the application and the data. Data is in your file. Now here, because of these complications, it is very hard to manage concurrency control. Now, concurrency control may sound like little heavy topic. Well, we will get into that later, but I can give you a very high level idea about concurrency control. Concurrency control is an issue that we need to address when the data is being accessed by more than one user. So we want to make sure that the data is accessed by the users in such a way that the data always remains consistent. And with file-based approach, data yeah, concurrency control is very difficult. Now, let's move on to the other disadvantage associated with file-based approach to database management. It's hard to integrate applications aimed at providing cross-company services, right? So it seems like slightly more complex application where we want the applications to kind of communicate with each other, uh, you know, interact with each other. Then at that place, this is going to be very, very difficult. All right, so what should we do now? Having understood the disadvantages associated with file-based approach to database management, let's move on to the kind of systems that we have now, which have been the result of decades of research in database systems or database management. Okay, so the systems that we have in operation these days, which are called database management systems or DBMS over here. This is how we store the data. So we are keeping the same kind of scenario because here again we have only three applications: invoicing application, CRM application, and GIS application. But look at the data. We don't have data in different files. In fact, the data is stored here, raw data. Okay, and then look at this part, DBMS, database management system. We will learn about what database management system is. We'll learn about its definition today. So because of the DBMS, what we will do, we will keep only one copy of the data. Okay, so duplication would be avoided. Again, this discussion is of a very what I should say beginning stage of the course on databases. So don't worry about it if you find me sounding kind of a layman. I'm avoiding technical details right now. So the DBMS that you have will properly store our raw data along with the catalog. In catalog, you will have metadata. Metadata is data about data. We will get into those details soon. So in this approach for data management using DBMS, our data is stored like raw data along with the metadata and catalog, and then the access to the data is being controlled by this component DBMS. All right, so DBMS will help us in creating this database, defining the database. First we should have definition, then the creation, and then a lot of things needs to be defined for the proper data management. All those things are taken care of by DBMS, but the access to the data is being controlled by DBMS. All right, so that kind of tight strong coupling that we had between the application and the data is not here, which is a great news. All right, so what I'll do now, I'll take you to the next slide where we have these advantages listed. So the advantages of database approach, here we go. It is superior to the file approach in terms of efficiency, consistency, and maintenance, right? So these are a few keywords that you should remember. Efficiency, yeah, it will be we can discuss efficiency in a number of parameters, but for the timing, let's just call it efficient. It is more efficient compared to file-based approach. Okay, because we don't have redundancy, first of all, right? That's one reasoning behind it, and we'll be reducing the storage space as well. All right, so there are multiple aspects in which our database approach is going to be more efficient. Yeah, this is consistent as well. You don't have any duplication, and the maintenance is also going to be easier. Now, loose coupling, right? If you remember the way in file-based approach, every application had to take care of reading the data from the file. Okay, the file structure should be known to the application. Whereas in this case, there's a loose coupling between applications and data, which is a great news. Now, it has facilities that provides for data querying and retrieval. So often in the DBMS that we use for our database, they come with their supported query language, like the more popular ones these days, like relational ones. You can think of these vendors like Oracle or this open source MySQL. So these are all database management systems, relational one, and they have a very what I should say, um, robust query language called structured query language (SQL). Okay, so that's also an advantage associated with database approach, which is not there in the file-based approach. It's all the responsibility of the application designer to think about the data access, retrieval, storage, and all that. Now, what we have here, I'll show you some example, right? Here, for the file-based approach, you will look at the pseudocode of an application where the application is taking the responsibility of reading the data from the file. So it's a pseudocode. Let's say that it has been defined as a procedure, find customer, and for that what you will do. Now let me put everything here so that you can have a look at the whole pseudocode. So your whole procedure is in between the begin and end, and in the procedure which is called find customer, you are opening a file customer.txt, and from there you are using customer, and then using a while loop, right? And this while loop is there to make sure that you're reading every record from this customer file customer.txt file. Therefore, you have a while loop written here, while not end of the file of this customer thing. You're reading this file, right? So I'm assuming that there is a read function that reads the customer text file. Okay, it's a pseudocode, so don't worry about the implementation details. Now here we are making use of an if statement to check whether the customer's name is equal to Bart. We are searching for a customer whose name is Bart. If that is the case, then we will display it. Otherwise, it's the end of the end of if statement, and you will read the next customer. So you're reading one customer at a time, all right, from this file, and it's your responsibility to compare the field name of each customer record with Bart, and if you find it, you will report that as success. Let's compare this approach with the database approach. Okay, so as I was saying that we will compare it with the most popular databases of the relational one. So in SQL, which is the query language of relational database management system, this whole thing can be written in just 3 statements. Okay, what are these? Select star. We will get into these details when I'll teach you structured query language, but I can explain to you. It's such a simple query. When we say select star, that means we are interested in all the records of that of the customer, and this data is coming from a table. We have this concept of table. We will learn about that soon. And from that table, we want all the records of only the person whose name is Bart. Okay, so here my intention is not to explain to you how a SQL query works. My intention is just to highlight the difference between the approach A corresponding to the file base and approach B that corresponds to the database approach. Database management, DBMS approach to accessing the data. All right, so with that much of this much of discussion, let's move on and try to understand a database system. Okay, and in that process, you will come across some definitions which are going to be very, very important for us. So before we go there, let's identify the elements, the important elements of a database system. What is a database system? We'll know that very soon. So the elements of database management, database systems include database model, versus instance. This is something we'll have to discuss. We'll have to discuss about data model. We will have to discuss the three layer architecture. It's a very important concept. And guys, I will be putting stars during my lecture, and the stars means important concept. Okay. So similarly, catalog is also a very important concept. We will look at the different kinds of database users, and we'll look at database languages. So let's see what we have first. So in the previous slide, if you remember, our first thing was database model. Okay, so let's see what is database model. Now I will first read these things and then I'll explain these things to you. A database model or a database schema provides the description of the database data at different levels of details, specified specifies the various data items, their characteristics, and the relationships. They also specify constraints, the storage details, etc. Okay, so what are database models? Database models, they provide descriptions of the data items that you'll be storing. Okay, but this description is provided at different level of abstraction or different level of details, you may call it. Now question arises, why do we need different levels? Okay, the answer to that is it's such a complex system that designing it at one level of description will not be efficient. So we use different levels of you know descriptions. So these things will be clear very soon when I'll take some examples. So when you're designing a database model, then the database model is specified during the database design, and this database model does not change too frequently. All right, so what I'll say, just bear with me. Okay, and these definitions might sound little intense, but they are not. The very moment I'll show you some examples, these will fall in place. So the database model is designed in the beginning of the database, right? At the database design state, and once the model has been perfectly designed, it will remain intact. It is not supposed to change that frequently. And this database model is stored in catalog. What is a catalog? We will look at that very soon. Now database model, we discussed about database model. Let's see what is database state. So this if you look at this heading of the slide, then it says database model versus database instances. So these database instances, they have another name which is called database state. Okay, so we have seen what is database model. Now let's look at database state. The database state represents the data in the database at a particular moment. All right, so these are database state represents the data in the database at a particular moment, and it is also called the current set of instances. So unlike database model, the database typically changes on ongoing basis. So yeah, I was waiting for this slide, right? Why? Because using that slide, you can understand database model. So let's assume that we are interested in building a database for university data. So in the university data, we will have these components to in our database. We'll have the data about student, we'll have data about courses, we'll have data about buildings. So at the database model level, we will determine that we are going to store our data in these components. Okay, so in the database model, you will come up with these components. How many do we have here? 1, 2, and 3. These are the three components we have identified. There will be many more. Professors are missing here, right? And the programs are missing here. There are so many components which are missing here, but we have kept it very simple, right? That's the reason only three components you can see here. So in database model, we will determine, or we will decide that the data about student will be stored in one component, and we'll have for student, the student's number, student's name, the address of the student, email of the student. Similarly, for course, we'll have course number and the course name. For building, we will have building number and the address. So these are all determined at database model level. Okay, and once you have determined it, you're not going to change it for your database. All right, now let's move on to database state. So database state comes into picture when you put the data in your data model. All right, so this is your data model, and here is the database state. So in the database state, what you have? You have three records for the student. Okay, and here let's think about the student component for the timing. Here we have these three students. More students may register, so the state will change. In place of 3 students, say 10 more students registered. Now we'll this whole what I'm avoiding the use of the term like table, but let's use that as table casually, right? So let's say in this picture we have 3 tables. In the top, you're looking at the student table. In the student table, we have 3 records there. So these 3 records determine the state of the student table. And for course, there are 3 courses. And then similarly for buildings, there are 3 buildings. All right, so this whole picture that you're looking at, right, this whole picture represents the state of your database, the database state. Why? Because in the database state, you look at the actual data which has been stored. And since the actual data will change with time, therefore the database state will change more frequently. Whereas in database model, the database model is more about the design of the database, okay, which doesn't change so often as database state changes. So guys, this difference between the database state and this topic, database model versus instances, would be interesting and important at the same time. Okay, so let's look at the data model. We have seen database model. Now we will get into data model. So guys, something I'm realizing at this moment is that probably I don't have the definition of database management. If that occurs in the next few slides, great. If that is missing in these slides, then I'll have those definition in the next part of this lecture. Okay, so I'm feeling that I should have that definition earlier, but that's okay. It will not make much of a difference. So having understood the concept of database model, let's see what is this data model. Okay, so important again. A database model is comprised of different data models, each describing the data from different perspective. Right now, this thing will make a lot of sense to you. Right, when I was explaining to you what is database model, then we said that we would need to describe the data, the database components at a different level of descriptions, right? But there we did not say what are these different levels going to be. But now here in data models, you will get those different levels of description. So one more time, database model. A database model is comprised of different data models. Each data model describes the data using a different perspective. And what data models do? A data models provides a clear and unambiguous description of data items and their relationships and various data constraints from a particular perspective. So perspective is important over here. And you would see that we would identify uh, I think 3 or 4 data models. And they are different because their perspective is different. One is very high level, so that is conceptual. Then there is logical. There will be conceptual data model, logical data model, internal data model, and external data model. All right. So all these data models, they are looking at the data. They are attempting to describe the data from a different perspective altogether. So as I said, we will start with the conceptual data model. Okay. So for a conceptual data model, our perspective is going to be different. It is high level perspective, right? So let me read it. A conceptual data model provides a high level description of data items and their characteristics and relationship. Very high level, okay? And we'll understand why do we need the description of data items at a higher level. Well, here is the answer to that. Well, I will read it and then I'll provide you the more explanation. The communication, the conceptual data model serves as a communication instrument between the information architect and business user. Now, what will happen in the next lecture, which is the part two of this lecture, I will discuss the different kinds of database user. And there you will learn about the information architect and business user. But I can give you some background here. So business user is a client for which you are building the database. Okay, so just think about a new university in Long Island. Okay, so there's a new university in Long Island and they want a database for managing their student registration. So now, and you are a software developer, okay? You have a company and you build the database applications. So you reach out to them and you need to understand their needs. So the business user now is going to be the university. Okay, so you might be meeting somebody from university, you might be meeting the dean of the university. Just think about a person representing the university. And here you are, the information architect is a techie. Techie who knows, right? I mean, how the data is designed and all, how the databases are designed. But this information architect will have this responsibility of understanding the requirement of the business user of the university, right? And the business user that the information architect is interacting with may not be a database person. All right, so the responsibility of this information architect is to properly facilitate the communication between the technicians who will be building this database and the end user or the business user. And for that reason, the model that the information architect has to use will be a conceptual data model. Okay, I hope it is making sense. Now, this conceptual data model should be implementation independent, it should be user friendly, and should be close to how the business user perceives the data. Right, so this point I believe is simple enough. Some of that I have already explained to you. Now, fine, right? We just saw the conceptual data model. Let's move on to the second kind of data model, which is called the logical data model. Okay, so conceptual data model was first. Now, logical data model is your second. And what logical data model does? This is the translation or mapping of the conceptual data model towards a specific implementation environment. Okay, so conceptual data model was perfect to understand the requirements of the business user, but that conceptual model is not sufficient for the implementation details. All right, it needs to be mapped to another model that we are calling as logical data model, which is more close to the implementation environment. Okay, and this is required because that is something that will be implemented later on, and you don't need to show your logical data model to the end user. So let's look at the example of some logical data model. So the logical data model could be a hierarchical model, could be a causal one, could be a relational one, could be object oriented, extended relational, XML, or NoSQL. Fine, right? So we did look at logical data model. Let's see what we have here. Now, logical data model can be mapped to internal data model, right? This is probably the third one, right? The third one is now the internal data model. So if you're following me along, you should see that in conceptual level, we had different perspective, very high level perspective. In the logical model, our perspective kind of got more towards the implementation. Okay, and then the internal data model, we are going further deeper in the implementation. What is this deeper thing? Let's explore that now. The logical data model can be mapped to an internal data model. An internal data model, what it does, it, it represents the data's physical storage details. Okay, so the physical storage details. Guys, the reality doesn't change. The reality is that the data is to be stored in bits and bytes, and that will be stored in the storage device, secondary storage device, right? But developing an application or developing a system, I would say, a database system, while thinking about the storage at the level of internal data is going to be an extremely inefficient and cumbersome process. That is the reason we think of different data models. All right, so your internal data model represents the data's physical storage details, and it clearly describes what, which data is stored, where, in what format, and which indexes are provided to speed up the retrieval. So all those details go inside the internal data model. And this internal data model is very much DBMS specific. This cannot be very general, right? This cannot be at the conceptual level. This has to be DBMS specific. Now here we go. There's the fourth one as well, right? So we have the fourth data model. What is this fourth data model? Well, this is called external data model. What do we have in external data model? External data model contains various subset of data items in the logical model, and these are also called views. Extremely important topic, and we will learn about views in more detail when we will be doing SQL. But for the time being, you can consider views as the example of external data model. And what external data models do, they are tailored towards the need of specific applications or group of users, right? So I don't want to explain too much right here because I have some very interesting pictures. I'll use those pictures to explain these things in more detail. So here we go, right? An extremely important picture and concept in databases, the three-layer architecture. So first of all, let's identify three layers. Okay, so I will do the bottom up thing. So internal layer, one layer. Then the second layer is over here, conceptual slash logical layer. And then the third layer is the external layer, right? So this is how the databases or the database management system is kind of understood, considering these three layers, because the system is so complex that you can't build that at one level. You have to think about these three layers. So what do we have in the internal layer? The internal layer corresponds to the internal data model, right? An internal data model has this detail, like how the data is being stored in disk, or what file for what file structure is being used, whether your data is on cloud, right? So all those details are handled in the internal level. And then you have the conceptual level. At conceptual level, you are not worried about the internal details, like how the data is being stored. At the conceptual level, you think of data as at a higher level of abstraction. As an example, if you are using the relational database, then you'll think about your data as being stored in different tables, right? Actually, the data is stored in bits and bytes, as I said, in different, storage devices, different locations and all, using the file structure, specific file structure. But At the conceptual level, we don't consider that detail. That detail is considered only at the internal layer. In the conceptual logical layer, you will think about you'll consider those as the logical data model. Okay. And then we have this top layer here, which is called the external layer. In the external layer, you're looking at three views. Let me put those as view A, view B, and view C. Now, the purpose of these views is to give a um, um, different customized behavior or outlook, I should say, of the database that we have. Because A, B, and C may correspond to three different class of users. All right. And then here we have these things, right? Physical data independence, logical data independence. What are these? We will discuss this in the second part of this lecture. Okay, so just remember this picture, and there's another picture coming up over here. Okay, so this picture you may consider as kind of a, little abstract, good for understanding the concepts, and here is the reality. Okay, so this abstract picture has been mapped to the reality or real life scenario where at the internal layer, you can have these, your servers you can think of, or data storage you can think of at different locations, say London, Washington, Moscow, where your data is stored in different storage devices, or you can think of clusters, warehouses, data warehouses, so on and so forth. So those details are that at internal layer. And then at the conceptual logical layer, we have the data model, if you remember, the data model thing, or the conceptual approach to the data, where you think of the data being stored for product, customer, invoice, and delivery. And for product, you have the information like product name, product description, the cost of the product, all these details. Similarly, for customer, you have the name of the customer, phone of the customer, address, so on and so forth. Similarly, you would have the understanding of the invoice. For invoice, you have these many uh, attributes we call technically, but you can think of different fields or properties or data items. Fine. At the external level, look at these three, right? So what are these three things? I will call them view 1, view 2, and view 3. What are these three views and why are they required? Well, the data is stored at one place, centralized. You'll say you're saying three different locations, but conceptually let's assume that we have all the data at one place, right? So what is required is that for a lot of reason, one of the reason could be the security, the other reason could be for convenience, for customization. We do not make the data available to everybody. No, we kind of authorize the data. We authorize the data, or we give the access to only we give only that part of the data to a user which is required for the user, right? So let me use this example here. The first view that we have is defined for the finance department. The second view is for customer service department. The third view is for logistic department. So all what these views are doing, these views are providing the customized representation of the data to different class of users, right? So they are achieving some customization, and that customization is important for security reasons as well. Okay, so this could be also important, right? So let me put the stars here. These understandings are extremely important. Okay, so now let's look at the catalog, which is a very important component of database and DBMS rather. So it is so important that it's called the heart of the DBMS. All right, and in the heart, what do we keep? This catalog. If you remember, in one of the picture, and this picture was about when we were comparing the file-based approach to database management versus the database management approach to data management. The data was stored in a raw, and we also had the catalog, and I put the metadata for catalog. So it's the same catalog. So catalog is the heart of DBMS. Catalog contains the data definitions, which is also called the metadata of your database application. All right, and metadata is extremely important. Not only that, the catalog also stores the definition of the views, the definition of the logical and internal data models, and it synchronizes these three different data models just to make sure that the consistency is guaranteed. All right, so this is it. Let me stop right here. The next part of this lecture or this chapter I will cover in a separate video lecture, and there I will have the definition of the DBMS database and all, which by accident I missed in this lecture slide. All right, thank you. Bye bye. Take care.